Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1, and we're on problem number 37. So this problem asks us to evaluate this limit. It's a pretty complicated limit. If we just try to plug in x equals 0, then we're going to get something like cosine of 0, which is 1, and then cotangent of 0. What's cotangent of 0? Well, tangent of 0 is 0, and cotangent of 0, cotangent is 1 over tangent. So what's 1 over 0? That's kind of like infinity squared, which is still infinity, and so this is what's called an indeterminate form. And I'll write that here. Indeterminate form. And the trick here is to turn this into a different indeterminate form, like 0 over 0, and then apply L'Hopital's rule. So the way to do that is to set y equals, I'm going to leave some room here, cosine x raised to the cotangent squared x. Now we're going to take natural log of both sides, and remember that when you take the natural log of something raised to a power, then the power can come out in front. So we have cotangent squared x times the natural log of cosine of x. And remember that cotangent squared x is the same thing as 1 over tangent squared. So that gives us log of cosine of x over tangent squared x. And this is good because if we evaluate this at x equals 0, we'll get cosine of 0, which is 1, and log of 1, which is 0. In the numerator, and tangent of 0 is 0, squared is still 0, so that's the indeterminate form that we were looking for. So now we can apply L'Hopital's rule to this expression. Okay, so let's apply L'Hopital. L'Hopital. So now, in order to apply L'Hopital's rule, we have to take the derivative of the numerator. So what's the derivative of the log of cosine of x? Well, derivative of log is 1 over whatever you're taking the log of. So that's going to be 1 over cosine x. And then chain rule, so we have to take the derivative of cosine x, which is negative sine x. And we're going to have to divide all of this by the derivative of tangent squared, which is 2 times tangent x times the derivative of tangent, which is secant squared x. Can we simplify this? Yeah. Let's see. 1 over cosine is the same thing as secant. So we can cancel out one of these secants. And tangent is the same thing as sine over cosine. So this sine can cancel out the sine that's inside the tangent, and then we're left with 1 over cosine, which is the same thing as secant. So actually that's going to bring back our square on that secant. So let's see, what this comes out to negative. This negative is still there. And then we have a 2 on the bottom, that's this 2, and a secant squared, which is the same thing as cosine squared on the numerator. Now, if we evaluate this at x equals 0, we will get cosine of 0, which is 1, squared is still 1, over 2. Okay, we're almost done. We finally got a number that's not indeterminate. And now we have to remember that this is not our answer, this is the natural log of our answer. So if we want to find what y is, we have to take the exponent of negative 1/2, which is the same thing as 1 over root e, which is answer B.